Xin chào. Nice to meet you. I feel honored to be here. I want to thank to the organizers at PostgreSQL for providing me with the opportunity to give this presentation. The title of my presentation is Parallel Loading a single copy data file using the PGM copy. I am very nervous. Sorry. This presentation explains the various tips and the result of consideration on how to load a very large single file data set into the database as quickly as possible. As quickly as possible. Let's begin. I am Joseph Kim from South Korea. I arrived yesterday with co-workers here. My Korean name, my Korean name is Kim Sang-gi. Joseph is my Catholic name. I've been using Postgres in production since version 6.5. It's a very long time. Come to think of it, Postgres has improved a lot since that time. I'm reading PostgreSQL DBAs at KTDS. KTDS is Korea Telecom Data System, a subsidiary at KT, Korea Telecom. My duty is the governance of a stable version of PostgreSQL used at KT. I guide DBA operation about Postgres and also development to how to use Postgres on new SI projects. And I search for root causes of instance or problems, and then I find workarounds. I formed the Korean PostgreSQL user group in 2005. I have been a member committee. I have been a member of a committee of PG Days Seoul event since 2016. PG Days Seoul event will be held, and this year will be 9th of it. Would it be okay? I hope to see you in Seoul this fall. This is my email. Here are the contents. Here are contents. I will talking about the history about parallel PostgreSQL. And next, I will describe the sample data for importing and exporting. Again, I changed the server parameters for that work. Explain that the copy command has a limitation. I made PGM copy and tested it, and I will explain how to improve create index. And lastly, I would like to offer suggestion to PGDZ group, Postgres Global Development Group for parallel copy processing. This is history. In version 9.6 and 10, parallelization of basic select queries was initiated. That was the beginning. In version 11, parallelized the DDL command like create index, alt tables, add primary key. In version 12, client programs became able to parallelize the multiple tables, which led to reduce the working hours of DBA. In version 13, vacuum operations was parallelized. The important things here is that when a table has multiple indexes, Postgres parallelized each index screening operation very well, but still, it cannot parallelize a very single table's screening operation. Version 14 enables parallelization in multi-instance environments. It was cornerstone for implementing sharding cluster. In version 15, Postgres became able to parallelize to select distinct syntax which had not yet been implemented. In version 16, it can parallelize the full join or right join queries. However, it still cannot parallelize the copy command. This inability is a disadvantage in many ways, especially if you have a lot of materials to load or dump in a single table. Parallel copy command was discussed at length by Postgres Global Development Group in 2020, but has not officially announced yet. My talk today is about exploring the parallelizability of a very simple copy operation. I will explain it with sample materials. In Korea, the government released the government releases hospital material history information every year. Anyone can look at anyone can look at the year's materials history of 1 million anonymous patients. The data is about 12 million cases, and the table size is 1.5 gigabytes. To handle the large amount of data, I target the 3 years of data. So total data is 37 million rows and 40.5 gigabytes. First, I copied that table to a file. It took 22 seconds. I checked the size of that dump file. It was 30.2 gigabytes. Next, I truncated the table for importing again, and then I copied that table from the file. It took 1 minute. Importing time took 3 times longer than exporting time. The reason is that the server write a write-ahead log and empty data phase to file. It is necessary to configure transaction log writing so that it does not interfere with data input as much as possible. I changed fsync off, synchronous commit off, and full page writes off. And I made a checkpoint timeout as long as possible. Also, set the transaction log size as large as possible. And then reload this configuration. Let's check again. Before changing configurations 1 minute, and then after changing 46 seconds. It was 25% faster. I wanted to know If there is any way to make it even faster, I still wonder, but here is something I came up with. Wouldn't it be faster to A, set it as an unlocked table, B, input data, and C, return it as a logged table? You can think about it, but time is to changing an unlocked table to a logged table is proportional to the amount of data. In other words, it will take longer to input the data as well as to changing the table properties. The \copy command in PostgreSQL is internally streaming using pipe. Therefore, it cannot be parallelized without pre-processing to 5 paths of the file. Before I work with it, I need to know the file format of the output of the copy operation. The file created by the copy2 command is each line, which is a single row. Which is the single row. Each column is separated by a tab character. Characters like null, new line, and tab are replaced with their respective escaping character as column values. The simplest way to import this file is to break it up into multiple tasks and to import the resulting file. To break it up, split it into one in-end files based on the total number of lines. Each of those files will be used with each one PostgreSQL command. You can parallelize the copy command by using the splits command, a Unix command that splits a large file into multiple smaller files. However, the file splitting operation itself takes time. Furthermore, the split process reads the file sequentially and splits it into multiple files. We cannot reduce the time to read the original file sequentially from beginning to end. Here are a second case to solve this problem. I made a new program. The program creates as many threads as it can parallelize, and each thread reads and imports only a path it needs to read. PostgreSQL COPY is a multi-thread copy program for PostgreSQL. This program is a prototype. Don't use in production environment. Pseudocode is as follows. Simply write. But these start and end points are not exactly in one in-end of the file size. This is because the copy materials has a variable length of one row. So we need to adjust the end of the material to be processed and then adjust the next start position accordingly. It creates enough threads to parallelize each operation with these adjust start and end positions, and each thread releases a satisfied amount from the file to perform the copy operation. This is performance. Next, so sorry. Okay. This is the data flow in PGM copy. Start from right to left. I asked ChatGPT to write this in C code. It's cheating. Sorry. And the resulting program is PGM copy. Of course, it didn't work. It didn't work as intended at the first attempt. ChatGPT wrote about 95% of the code, and I did some work with buffering and exception handling to make PGM copy use memory efficiently. Here is the execution history. The final job took 25 seconds. It was twice as fast as PGSQL. Also, I did speed comparison based on the number of threads. This is comparison chart. A single thread took 36 seconds. Meanwhile, 16 threads took 14 seconds. The test machine is like that. It's very fast. As you can see from the chart, when I loaded the data by multi-thread, the inputting time was faster, even though it was a single table. Comparing to a single PostgreSQL copy operation, I could see that it was more than 4 times faster, from 16 to 15. So far, we haven't considered the table's primary key and index. In production, it is extremely rare. Extremely rare to use a simple table with no attributes like that. Let's think about it. How to input data in a production environment? We need to do 3 works. The first part is the SQL script that creates a table with no attributes. And the second part is to use PGM copy. And last, the script to create constraints and indexes of the table. It's very annoying. Also, when you do this, alt table or create index, maintenance workman and max parallel maintenance workers should be tuned appropriately to speed up. 64 megabyte of memory and 2 workers are a default value. In a typically enterprise database situation, this is too small, especially for large table management tasks like this. I changed them to 6 gigabyte and 6 workers and faster. 얼마가 될까? 3 minutes to 2 minutes. Because PostgreSQL has the ability to create index in parallel. To conclude my presentation, I'd like to make the following suggestion to PostgreSQL developers. Parallelization of the copy command is a must. If it cannot be implemented on the server side, I would like to see It's supported in client programs such as PGSQL, pgdump, and pgrestore. Plan 1, this is for PGSQL. Create a new built-in command called pgmcopy. Command is for output, above and below. Command is the input. Okay. The parallel PG restore or PG dump program is roughly same sort. That's all I have prepared for you today. If you have any questions, email to me. Please email. Thank you for your patience.